Hey everyone, so for my Jedi lesson, I am going to be talking about electric forces. So before we get into the heavy physics stuff, have you ever wondered why your clothes cling together like crazy when you pull them out of the dryer? Or like why when you rub a balloon on your head, your hair seems to stick up? Well, it's actually just physics. It's all about electric forces. And believe it or not, these same forces are literally what hold our bodies together. So let's get into it. Okay, so what's an electric force? Well, to understand it, we basically have to zoom way, way in because electricity starts in an atom. So let me just draw our little atom here. We have electrons. So atoms have a nucleus in the middle packed with positive stuff, which we call protons. So I could depict it with blue, the protons. And then around that, we also have this cloud of negative stuff, which are electrons, which I could depict in maybe green. So Um, so the big rule of the universe here is that the opposite charges attract and the like charges repel. So unusually atoms are neutral. So but when you do something like rub a plastic rod with a piece of wool, the friction actually breaks the bonds and electrons get ripped off one thing and transferred to another. And so now you have things with unequal charges and they start pushing and pulling on one another. So to actually calculate this push or pull, we use Coulomb's law. And Coulomb's law is basically just that F is equal to K Q1 Q2 over R squared. And so here's what these variables mean. So F is the electric force, and we measure it in newtons. And then K is a constant, which is basically just um 9.0 times 10 to the ninth. Q1 and Q2 are the amounts of charges of two objects, which are measured in coulombs. R is the distance between them, which is measured in meters. And notice that R is squared on the bottom, which means that if you move two charges further apart, the force drops off super fast. So let's explore this with a quick problem. So imagine you have two massive charges locked in place. So we could draw two horizontal lines and then we will draw a little circle and then 10C. Let's just wait, let's see. 10C at x equals 0 meters. And wait, let me just change the color real quick so you guys could see. At x equals 0 meters. Okay, so we have a 10 coulomb charge here at x equals 0 meters. And then we have a 20 coulomb charge at x equals 10 meters. And let me just make it bigger. So we have a 20c at x equals 10 meters. Okay, so we have these two circles and both are positive, so they hate each other. They want to push apart. So now let's say I hand you a 1 coulomb charge. Where would you want to place it on this line so that it feels exactly zero net force? So you have this charge, that's 1 coulomb. So we need to force we need the force from the 10 charge to equal the force from the 20 charge, right? So that means the distance from the 20 coulomb charge is 10 minus x. So setting them equal using Coulomb's law, so F1 equals F2. So if we set that up and we input it into our equation, that will be 10k 10 1 over x squared, because remember our equation here, over x squared is equal to k 20 1 over, and remember I said 10 minus x squared, right? Because, yeah. So the cool thing here is that k and the 1 just cancel out on both sides. Okay, so we could just cancel out k and 1. And so that will just leave us with 10 over x squared is equal to 20 over 10 minus x squared. And so if we divide both sides by 10, if we divide both sides by 10, we would get, let me change my color here, 1 over x squared, because we're trying to get rid of this 10, right? 1 over x squared is equal to 2 over 10 minus x squared. And then if we take the square root of both sides to make our lives easier, obviously, we could just take the square root of both sides. That would just leave us with 1 over x is equal to square root 2 over 10 minus x. And then if we just cross multiply and solve for x, like cross multiply, then we would get 10 minus x is equal to the square root of 2 and then x. And then solve that further, we would like make it solving for 10. 10 is equal to, like, isolating x plus square root 2x. And even further, 10 is equal to x 1 plus square root 2, which further, to finally solve for x, we will get x is equal to 10 over 1 plus square root 2. And so if you punch that into a calculator, x is about 4.14 meters. So you'd have to place it closer to the 10 coulombs. 10 coulombs charge, which totally makes sense because the 20 coulomb charge is a lot stronger and would push harder. So you'd place it probably like around here, maybe like closer to the 10 coulomb charge. So remember how I said it holds us together. So the electric force is actually what holds our DNA together. The two sides of the DNA double helix are connected by bases of adenine and thymine, because of their specific shapes and the tiny positive and negative charges on the atoms perfectly line up, and that electric attraction pulls them together. So the next time your clothes stick together in the dryer, just remember that the exact same force that is annoying while you fold laundry is also holding the very blueprint of your very existence together. Thank you.